At this point in the module, I've already introduced you to the idea of impulse. We say that if a force acts on a mass for a time delta t, then the force delivers an impulse to the mass, and that impulse is defined as the force vector multiplied by the time for which the force was acting. We saw in the previous video that the impulse delivered to the mass is equal to that mass multiplied by the change in the velocity of the mass, which occurs as the impulse is being delivered. Another way of expressing that is to say that the impulse delivered to the mass is equal to the mass itself multiplied by the difference of final velocity minus initial velocity. In this video, we're going to apply the idea of impulse to a situation in which two masses collide with each other. So let's look at the initial situation. We have here mass 1 and here mass 2. Mass 1 is moving to the right with a velocity v1 initial. Mass 2 is moving to the left with a velocity v2 initial. Since the masses are moving towards each other, we know that at some point there's going to be a collision. Let's say that during the collision, mass 2 exerts a force on mass 1, which we will call F2 on 1. And at the same time, mass 1 exerts a force on mass 2, which we will call force 1 on 2. Let's also say that those masses are exerting those forces on each other for a time interval delta t. The result of the collision is that when the masses separate after the collision, they have new final velocities. In the final situation, mass 1 has velocity v1 final, and mass 2 has velocity v2 final. During that collision, what would be the impulse that mass 2 delivers to mass 1? To answer that question, let's go back to the definition of impulse here. Impulse is defined as the force that acts multiplied by the time for which the force is acting. So the impulse that 2 gives to 1 would be equal to the force that 2 exerts on 1 multiplied by the time for which the force acts. We can also ask, what is the impulse that mass 1 gives to mass 2? Again, using the definition of impulse, we can say that the impulse 1 gives to 2 is equal to the force that 1 exerts on 2 multiplied by the time for which the force acts. What we would like to do now is find a relation between the impulse 2 gives to 1 and the impulse 1 gives to 2. Before I give you the answer, I would like you to try this on your own. See if you can remember something we learned earlier in the course that relates force 2 on 1 to force 1 on 2. If you can remember that, see if you can then use that relationship to then get a relationship between the two impulses. So give that a shot and then rejoin the video. To get a relation between the two impulses, let's start by writing down Newton's third law of motion. Newton's third law of motion says that the force that mass 1 exerts on mass 2 would be equal to minus the force that 2 exerts on 1. Now let's multiply both sides of this equation by delta t. We would then get force 1 on 2 times delta t equals minus force 2 on 1 times delta t. You can notice here that the expression on the left side of the equation is just equal to impulse 1 on 2. And the expression on the right side of the equation is a minus sign followed by this, which would just be the impulse 2 gives to 1. So on the right side of the equation, we have minus impulse 2 on 1. So there we go. This is our relation between the impulses that the two masses deliver to each other. The impulse that one gives to two is exactly opposite of the impulse that two gives to one. This is a direct consequence of Newton's third law of motion, and you can see that it even looks a lot like Newton's third law of motion. To help us visualize this result, you can see that I put in an extra figure here. We have two masses colliding with each other, and in that collision, each mass delivers an impulse to the other. According to the result that we just obtained here, these two impulses are equal in magnitude and exactly opposite in direction. In the next video, we're going to begin using this result to analyze situations where two masses collide with each other.